What's up, 7th grade? Mr. Pistel here. I have a mystery for you to start this class. So how did two Mesosaurus end up on two different continents that are so far apart if they can't swim across the Atlantic Ocean? So we have a Mesosaurus on South America, on the east coast of South America, and we have a Mesosaurus fossil on the west coast of Africa. What's your explanation for this? And no, they did not swim across the ocean. And no, this picture is not to scale. Mesosaurus were not this big. So the answer lies in something called tectonic plates. So the Earth, you can think of like a Hot Pocket, if you've ever eaten a Hot Pocket. The inside of a Hot Pocket, after you put it in the microwave, is kind of like molten cheese and meat and all this kind of stuff. And Earth is similar because the center is extremely hot and mostly liquid. Iron, and we also have like the mantle, which is just a lot of hot swirling liquid basically. But the outside of Earth is basically a thin solid crust, just like there's a thin layer of crust on the outside of a Hot Pocket. So we call this outside the lithosphere or crust. Now this crust is not all in one piece. This crust is divided into several tectonic plates. Another word for that is continental plates. And these plates actually float around. These solid plates, the solid crust, floats around on a layer of liquid that we call the mantle. And because they're kind of floating around on this mantle, they move. So moving tectonic plates is part of the explanation for these two Mesosaurus being so far apart now. So let's look at these. This is a very crude drawing, but you get the idea. The Earth is divided up into plates, solid thin plates, kind of like an eggshell. But underneath you have this mantle layer, mantle, liquid. This is a better model because it actually shows some of the numbers involved. So if you look at this, from the outside of the Earth to the center of the Earth is about 6,000 kilometers. We have an inner core of iron, which is the reason for Earth's magnetic fields. That's actually solid. We have a liquid iron core, outer core, that's surrounding the solid inner core. We have layers of mantle, and all this is liquid and it is moving, and it's going to push around this very, very thin layer of lithosphere. And we also see that sometimes a layer of ocean or water can be above the lithosphere. So actually, 70% of Earth is covered in water above the lithosphere. But those are both very thin layers. Now, your assignment for today is to use several pieces of evidence to arrange the tectonic plates. So the tectonic plates we have now have moved a lot for the past 300 million years. But a long time ago, all the tectonic plates were together to create a supercontinent called Pangaea. And I believe you studied this. Oh, hello, Taz. I believe you studied this back in 5th grade. So I'm not going to reveal the answer yet. I have some videos about Pangaea, which I'll reveal tomorrow. But what I want you to do is to try to move around these puzzle pieces and create Pangaea. So we have this gizmo, which is in school we usually cut out the pieces and arrange them physically like a puzzle, but this is almost the exact same thing on computer that I found. So when you launch this gizmo, you're actually only going to have 5 minutes unless you set up an account like me, which I don't recommend necessarily. Just try to do it in 5 minutes. So I'm going to full screen it. Okay. I'm definitely going to use fossil evidence. I can only select one at a time. You know, I think you should start with fossil evidence. And also the shape of the continents themselves. So basically, if I click on... My goal is to get all the continents in one piece that shapes together nicely like a puzzle. So if I have fossil evidence, that means that... let's look at Mesosaurus, which is blue. That means that there was Mesosaurus here and Mesosaurus here. So I want to try to bring those together. So if I click on South America, I can move it around. I can actually rotate it. Boom. So the Mesosaurus lines up. The Glossopteris plant lines up. The Cygnognathus organism, whatever that is, lines up here. And also you'll notice that South America and Africa fit together perfectly because they did used to be together. So what I want you to do is use the shape of the continents and the fossil evidence of the continents to try to create a Pangaea. And then I want you to screenshot that and submit that as your assignment for the day. If you're stuck on fossils, do what you can with fossils, but then move on to rock evidence. So maybe from this rock evidence, I would know that this part of North America and this part of Europe line up, probably. And there's a little bit here too. Glacier evidence, which we never dealt with in previous years, but maybe that'll help you. But I prefer the fossil evidence. So try to arrange the puzzle, and you only have 5 minutes if you're using the, if you're not signing up for an account, which I don't think you should sign up for an account. So this assignment should only take 5 minutes. Screenshot it, and that's it for today.